Hello, welcome to Presume Technologies. I am Venkat. This is part 52 of SQL Server. In this session, we'll understand what database normalization is all about, list the different normal forms that are available, and we'll also learn how to put a table in the first normal form. So what is database normalization? Database normalization is a step-by-step process of organizing data to minimize data redundancy, which in turn ensures data consistency. So what do we mean by data redundancy? Duplicated data. Data duplication is nothing but data redundancy. Okay, let us see with an example how data redundancy can actually lead to data inconsistency. Now we have a table here which has got employee name, gender and salary, and along with that we also have the department information in the same table. Now if you look at the department information, we have department name, department head and department location. Now if you look at the IT department, there are 3 employees within the IT department: Sam, Simon and Todd. And look at this, for these 3 employees, all the 3 columns, department name, department head and department location, all these 3 columns are repeated. Okay, now let's assume in the IT department there are 5,000 employees. Obviously we'll have to repeat department head and department location columns along with the department name. So what is the disadvantage? The obvious disadvantage is that disk space wastage. Okay, so if there are 50,000 employees in IT department, I'm going to repeat department name, department head, department location 50,000 times. Obviously there's a lot of wasted disk space, which is directly proportional to the number of rows in the table. As you increase the number of rows, the disk space also increases. Okay, so the second problem is data can become inconsistent. Okay, let's understand how data can become inconsistent. Now let's say at the moment department head for IT department head is John. Now let's say John has resigned and we have a new IT department head, Steve. Okay, so we need to update the department head. So now if you have to change the department head name for IT department, and let's assume there are 50,000 employees in IT department, you will have to update all the 50,000 rows. Just imagine what could happen if you forget to update a few rows. Obviously, if you do that, the data is going to become inconsistent. Okay, so for some of the rows, in some of the rows the department head will be John, and in some of the rows the department head will be Steve. So we will not actually know who is the actual department head. So your data is wrong, it's inconsistent. So, and why did we land in this problem? Because of the duplicated data. So data redundancy can actually lead to inconsistent data. So if you reduce data redundancy, your data is going to be consistent. And obviously another problem is DML queries can be slow. What are the examples of DML queries? Insert, update, delete. Now let's say I want to update department head name from John to Steve, and let's assume there are 1 million employees in IT department. Obviously we will have to update 1 million records. Obviously that update statement is going to take time. Okay, so these are the problems of data redundancy: disk space wastage, data inconsistency, and your DML queries can become slow. Okay, so obviously to solve this we will normalize the tables. Now this table is normalized here. If you look at this, we actually have broken down the table into 2. So we have department table here, department ID, department name, department head, department location columns. Okay, and then we also have given a primary key to uniquely identify each department in this departments table. And then what we are doing in the employees table, we are only having employee name, gender, salary, and then the department ID to which they belong. So obviously we have broken this table down into 2, and then whatever are the repeating columns, we have moved that to a separate table. Okay, so now we don't have to repeat department name, department head and department location in the employees table. All you do here is refer the department ID. Okay, so even if there are 50 million employees in the IT department, you ever are going to have one row for IT department in TBL department table. So if you want to change the department head from John to Steve, you only have one row to update, no matter how many employees are there in that department. Okay, so obviously here the data will be consistent. So when you join this employee table with TBL department, we're going to get consistent department names, or department head names for a specific department. Okay, so this way, normalized table design can reduce data redundancy, which in turn can actually save space. So we are saving a lot of space here. And your DML queries can also become faster, because just imagine updating 50 million rows and updating just one row in TBL department table. How fast the DML query can be. Basically, database normalization is a step-by-step process. This is just an example that we have seen until now. Okay, so database normalization is basically a step-by-step process. There are 6 normal forms: first normal form through 6th normal form, 1NF, 2NF through 6NF. Most databases in the real world are in 3rd normal form. And there are certain rules that each normal form has to follow, which we'll be talking about in the next video series. Today we'll also discuss about first normal form. So what are the rules that a table should follow if it has to be in the first normal form? Okay, first of all, the data in each column should be atomic. No multiple values separated by commas. What do we mean by this? Let's look at an example. So here, if you look at the table here, I have the department name and employees within that department. If you look at this, the employee column here is not atomic. Why? Because you are storing multiple employees in the same column, separated by commas. So these values are not atomic. So the data in the employee column is not atomic. In the department name it's atomic, but in the employee name it's not atomic. There are multiple values separated by commas. Now what are the problems of non-atomic columns? Obviously, if you want to select, insert or update or delete just one employee, it's not possible. For example, let's say I want to remove Mike. You have to update this entire cell. Okay, so you can't just remove Mike from there. Okay, you have to update the entire cell. So that's the problem with non-atomic columns. Okay, so obviously if we don't want to have this, another design that we can think of is something that you can see here. Now if we want to have atomic values, I know that in a department there are 3 employees, so let me create 3 employee columns in the same table. So department name stays as is, but then for each employee I'm creating a separate column. So employee 1, employee 2, employee 3 column. Okay, so that I can store Sam, Mike, Sean in their own cell, in their own column. So now in this table each column is atomic, but then because of this design you have introduced another problem, repeating column groups. So if you look at this employee column, it's actually repeating itself: employee 1, employee 2, employee 3. So a table should not contain repeating column groups. Why? There are several problems associated with repeating column groups. So what are those problems? Now if you look at the design, the maximum number of employees that can be present in a department is 3. Now let's say there is a new employee joining in the IT department. Where will you store him? You have to alter the table structure. And altering a table structure is not a good practice, because there could be applications referring to that table already, and you may have to modify those applications as well. Okay, so obviously you have to change the table structure here if there is going to be a 4th employee in any department. On the other hand, look at this. HR department has got only 1 employee. So obviously employee 2 and employee 3 columns will be null. So what's the problem? Wasted disk space. Okay, so with repeating column groups, you either have to change the structure of the table if there are more employees going to be in that department, or if there are fewer employees than the columns that we have, we are going to waste the disk space. Okay, so how do we put this table in a first normal form. Obviously, to do that, we are breaking this table into two. Okay, department table here that you can see. What we have done basically is we have in the department table we got department ID. We have given it a primary key to uniquely identify each department within that table. So department ID 1, ID 2, HR, and then the repeating employees, we have put them in another table with department ID as a foreign key. So in the IT department there are three employees, Sam, Mike, Sean. So what we are doing here, we are having one employee column and one department ID column. So Sam, Mike, Sean, their department ID is 1. So we know that these three people belong to IT department. And then department ID 2 is HR. Pam is in the HR department. Okay, even if a specific department is going to get 100 employees, we don't have a problem now. We will simply have more rows with that department ID. Okay, so now this structure is in first normal form. Why? The data in each column is atomic. If you look at the data in each column, it's atomic, no multiple values separated by commas, and the table does not contain any repeating column groups. There is no column, there's no column like department name 1, department name 2. Similarly, there's no employee 1, employee 2, employee 3, etc. The column groups are not repeating themselves. And in this departments table, we are able to uniquely identify the record using the primary key. And then to find out which employee belongs to which department, we are actually using department ID as the foreign key in this table. So all the rules are satisfied. So this design is said to be in the first normal form. In the next video session, we'll talk about how to put a table in the second normal form. On this slide, you can find resources for ASP.NET, C# and SQL Server interview questions. That's it for today. Thank you for listening. Have a great day.